let us start. Today we are going to discuss the Laplace equation solution. So the Laplace equation is del square phi equal to 0. So del square phi equal to 0 is called Laplace equation. Right, so this has many applications, right? In the electromagnetic fields, we do have the applications of this, and even in fluid mechanics also we have the applications of this, and even in the heat flow equations also we have the application of this Laplace equation. So ideally, this is dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square equal to 0. So this is called the Laplace equation. Now in this, actually, this is a 3D Laplace equation, and dou square phi by dou x square plus dou square phi by dou y square equal to 0. This is 2D Laplace equation, and dou square phi by dou x square equal to 0. So this is 1D Laplace equation. Now actually each has its own applications. Now actually the most common equation is this one. So this is what we are going to solve it now. So this is del square phi equal to 0 in case of 2D. Got it? Now the procedure exactly follows the way we have done in case of either in the wave equation or in the heat equation, right? So here this is actually one more equation. So exactly the solution follows now exactly in the similar manner. Dou square phi by dou x square plus dou square phi by dou y square, this is equal to 1 by c square dou phi by dou t. Now this is a two-dimensional heat flow equation. Now on steady state, if you consider the steady state, then the dou phi by dou t will be obviously equal to 0, because this is the analysis of steady state. Now in that case, so this equation becomes dou square phi by dou x square plus dou square phi by dou y square equal to 0. So which is nothing but the Laplace equation, which is an application of the analysis of the heat under the steady state condition in two dimensions. Got it or not? So this is the Laplace equation. Now actually we are going to solve this, how it is going to be. So this is one of the application. Even for the heat flow, we are going to apply the same Laplace equation, but two dimensional. So assuming the steady state condition, which means dou phi by dou t equal to 0. So yesterday actually when we solved the heat equation, we assumed the steady state conditions. There actually one dimensional steady state actually we have assumed. Now there actually dou square phi by dou x square will be equal to 0. So that is straightforward and simple. Got it? So even if you notice actually dou square phi by dou x square equal to 0. If you integrate once, then dou phi by dou x is equal to some constant a. And then if you integrate again, phi is equal to ax plus b. If you notice yesterday actually when we dealt with the steady state conditions, we have got the equation of the form 60x by L plus 20. So this is how actually we have got it. Don't you think that actually these two are the same? That is nothing but a one-dimensional heat equation under the steady state condition. Now what we are going to analyze is a two-dimensional heat flow equation under steady state condition, which will lead to dou square phi by dou x square plus dou square phi by dou y square is equal to 0. Got it or not? Understood what we are going to do it? Okay, great. So note down this. Then actually let us find out the general solution of the Laplace equation, which is most common equation, and it is applicable. It is having the applications to a wide range. So it has applications in electromagnetic, it has applications in the heat flow, and it has applications in the fluid flow. These are the three common applications where this was built. Now, if you find out the solution of the Laplace equation, that is dou square phi by dou x square plus dou square phi by dou y square equal to 0. So this is the Laplace equation which we are going to solve it. Now if you want to solve this equation, then assume that the solution to be phi is a function of x of x and y of y. So it is a product of two different functions which is completely a function of x and which is completely a function of y. Now from this equation, dou phi by dou x is equal to x dash y, and it implies dou square phi by dou x square is equal to x double dash y. Similarly, dou phi by dou y is equal to x y dash. It implies dou square phi by dou y square is equal to x y double dash. Now, if you substitute in the original equation, so del square phi is equal to, this is going to be x double dash y plus x y double dash equal to 0. Or in other words, this equation can be written as x double dash y is equal to x into y double dash, or x double dash by x is equal to, so this is minus of, y double dash divided by y minus of. So this, I call this as the constant k. Now actually we have got the general equation format for us. Now for this, so let the case 1. So let k equal to 0. Then actually if k equal to 0, then this is going to be x double dash equal to 0 and y double dash equal to 0. It implies x actually we just solved it. If you integrate 2 times, then this is going to be ax plus b format, and this is going to be or c1x plus c2, and y is equal to c3x c3y plus c4. Got it? So the final solution phi is going to be xy, which is given as c1x plus c2 getting multiplied by c3y plus c4. So this actually usually used in case of electromagnetics. So this kind of equation is applicable there. So that's why actually we are going to use this. Got it? Now the case 2 part is, in case of case 2, let k equal to p square. Now if k is equal to p square, then x double dash equal to p square x, and x double dash minus p square x equal to 0, and then this is y double dash equal to minus p square y, or y double dash plus p square y equal to 0. Now the auxiliary equation for this is m square minus p square equal to 0, m is equal to plus or minus p, and here m square plus p square equal to 0, m is equal to plus or minus ip. Now the complementary function for this, which is nothing but x equal to c1 e power px plus c2 e power minus px, and here the general solution, that is the complementary function, is going to be y is equal to c3 sin px plus c4 cos px. Got it? So the final solution is going to be phi is equal to xy is equal to c1 e power px plus c2 e power minus px getting multiplied by c3 sin px plus c4 cos px. So this is the solution. Got it? So this is case 2. Note down till this point. How x? Which x you wanted? Which one, Liju, you are talking about? So here actually x, and here it is going to be y. Sorry, this is y. Yeah, you are correct. This is y. Got it? Yeah. Yeah, it's corrected. Yeah. Done? Noted? Okay. Yeah, so this needs to be derived actually during the time of examination. So first of all, actually which solution you wanted to opt, right? That needs to be mentioned clearly out of all the three solutions. You have to derive it and then select it. But it won't take much time, I think. Is it done? Okay. Now actually, so if you take case 3, then this is going to be minus p square. So in case of case 3, so k is equal to minus p square, then x double dash is equal to minus p square x and y double dash equal to p square y. Again, this is going to be x double dash plus p square x equal to 0, and the auxiliary equation is p square m square plus p square equal to 0, and m is equal to plus or minus ip, and the complementary function is, this is x is equal to c1 sin px plus c2 cos px. This is the complementary function, and here y double dash minus p square y equal to 0 and y is equal to plus or minus p, then complementary function is going to be, m is equal to m square minus p square equal to 0. The complementary function y is going to be c3 e power py plus c4 e power minus py. So the final solution phi is equal to x into y is equal to c1 sin px plus c2 cos px, c3 e power py plus c4 e power minus py. Got it? So this is the solution. Now out of all the three solutions, we have to select it. Yeah, Avinash. So actually this will consume the space definitely, but actually I think so in UPSC they will give you appropriate space for each question. If it is 10 marks, actually you don't need to derive all these things. If it is for 20 marks or 30 marks, then you have to derive all these things here. Done? Noted? Now, from this actually, the solution of the Laplace equation, we have three different forms. So, here, the one solution is C1x plus C2 into C3y plus C4. So this is one solution for phi. And the second solution is, so second one is C1 e power px plus C2 e power minus px getting multiplied by C3 sin px plus C4 cos px. This is another solution. And similarly, phi 3 is the another solution. C1 sin px, sorry, this is y. This is y. Yeah. So sin px plus C4, C2 cos px getting multiplied by C3 e power py plus C4 e power minus py. So these are the three different solutions that we have got as part of the general solutions of the Laplace equation. Now, out of all the three solutions, so the selection has to be done that is more appropriate to the initial conditions. So this is how actually you have to select the solution. Got it? Now based on this understanding, note down one problem. An infinitely long plane, uniform plate, an infinitely long plane, an infinitely long plane, uniform plate is bounded by two parallel edges. Is bounded by two parallel edges. Bounded by two parallel edges and an end at right angles to them, and an end at right angles to that. The breadth is phi. This end is maintained at a temperature U. The breadth is and this end is maintained at a temperature U naught. At a temperature U naught. At all points and other edges are at zero temperature. Other edges at 0 degrees centigrade. Determine the temperature at any point of the plate in the steady state. Temperature at any point in the steady state. So this is the problem statement. Here actually this word is very crucial to understand. Steady state. Here actually if there are two different dimensions that are specified and one inherent dimension is time, then the heat equation a general heat equation is del square phi is equal to 1 by c square dou phi by dou t. So this is actually a general heat equation. Now out of this general equation, so under steady state condition, dou phi by dou t equal to 0. So this is steady state condition. And then del square phi equal to 0. So this is 3D. For 2D, it is going to be dou square phi by dou x square plus dou square phi by dou y square equal to 0. So this is the equation what we are going to solve it now. Got it? So, but this conclusion you have to make it before starting the problem. Got it? You have to explicitly mention this. So note down this in problem statement and the analysis. Now actually we are going to solve this. Is that noted? Okay. Now actually, first we draw the diagram, what he is expected, and then based on that we will proceed further. Just a minute, I am getting a call. Okay, yeah. So now actually, yeah, sorry. Fine. So here actually, so del square phi actually, now we have got the equations. So this is how actually it is. Now let us say this is x axis and this is y axis, and then this is the plate actually he is trying to heat. Now in this actually what he did was, so this is at infinite, assume that this is at infinite, and this is a length of pi. This is pi, and this is negative x-axis and this is negative y-axis. So this length of pi, and this is maintained at 0 degree centigrade. So this is u of 0 comma y is 0, and this also he maintained at 0 degree centigrade, that is u of pi comma y is again maintained at 0, and then this is maintained, that is u of 0 comma x is maintained at temperature of u naught, say a constant temperature. Now obviously he didn't mention anything here, that means u of x comma y or x comma infinite, this is maintained again 0, because he didn't mention anything. Obviously if you try to heat only at this particular point, this edge is maintained at 0 degree centigrade, and this edge is again maintained at 0 degree centigrade, and this edge is simply left it, but this is maintained at U0 temperature. Obviously, over the steady state, this is going to be 0 temperature, right? Yes or no? Understood or not? Based on this understanding, now actually, out of all the three different solutions, you tell me which is more appropriate solution for this based on the initial conditions. Which will be best suited for us? Can you try to research on that? Out of the three solutions, left edge is 0 degree centigrade, right edge is 0 degree centigrade, bottom edge is at U0, and topmost edge that is at infinity is going to be again 0 degree centigrade. For that scenario, what is the most appropriate solution that we can think of out of 5.1, 5.2, 5.3? Which is most suited for us? Lizu, why did you select that option? So that solution actually, so this will not fit for us. Why? Because in this equation, if you notice, this boundary condition where y is tending to infinite, so this value is going to become infinite, right? But actually, ideally, this temperature is 0 because as you keep on move from the x-axis, so this temperature is coming out to be 0. So this won't fit for us. And then what about the second equation? Will it fit? That also will not fit. Why? Because just see this from this diagram. If you notice, this is at 0 degree centigrade, this is at 0 degree centigrade. In between, this is maintained at U0. That means if you notice, this temperature is going to be this particular format, right? Correct or not? So this is as if like it may contain either sine or cos. That means x should be, so this is the x variation should be either sine or cos. But the y variation, right? So this is maintained at U0 and it keeps on goes away. So this is going to be exponential, right? E power y. Got it or not? So it will be exponentially decaying as it keeps on moves away from this constant temperature. Now, obviously, based on this understanding, we have to pick up the appropriate solution. That is, x should be in terms of sine and cosine, and y should be in terms of y, because the y will contain the exponential aspects and x will contain the oscillations, that is the sine or cosines. That means the most appropriate solution phi 3 is equal to c1 sin px plus c2 cos px getting multiplied by c3 e power py plus c4 e power minus py. So this will be the appropriate solution for us. Is this understood, others? Yes or no? Is this understood or not? Any questions? Anybody? Yeah, great. So once you understand this aspect, then actually you can apply the boundary conditions to solve this Laplace equation. So the procedure again it is same. So whatever we applied for the heat equation and the wave equation, the same thing actually even we apply even for the Laplace equation. This length is pi and this is u of 0 comma y is 0 and u of pi comma y is again 0 and u of x comma infinite is 0, but u of x comma 0 is u naught. So these are the boundary conditions. Now actually if you apply the first boundary condition u of 0 comma y is equal to 0, then phi of 0 comma y. So this is c2 into c3 e power py plus c4 e power minus py. So this is going to be 0. Then being y is non-zero value, c2 will be 0. And then the second boundary condition. So from this actually phi of xy will become, this is c1 sin px into c3 e power py plus c4 e power minus py. Take the other boundary condition, that is phi of pi comma y. This is again 0. So c1 sin p pi c3 e power py plus c4 e power minus py. This is going to be 0, or in other words this is sin py. It implies sin p pi equal to 0 equal to sin n pi. So it implies p is equal to n. Now if you replace that equation, phi of x comma y is equal to c1 sin nx into c3 e power ny plus c4 e power minus ny. Right? So now actually we have got two different solutions. Then the other solution is u of x comma infinite. Yeah. So this is u of x comma phi of x comma infinite. If you replace this is c1 sin nx c3 e power n into infinite plus c4 e power minus n into infinite. Now if you notice, this part will be 0 and this part will become infinite, right? So as you keep on increase the value of I, this part is becoming 0, but ideally the boundary condition says that this value is going to be 0. Then the only possibility of having this to be 0 is c3 equal to 0. It implies c3 equal to 0. Then the solution is going to be phi of x comma y is equal to c1 c4 sin nx into e power minus ny. Now see this. This is ideally coming to satisfy this equation. Earlier I told you this should be a kind of sinusoidal or cosinusoidal variation in the x direction, that is nx, and in the variation of the y should be an exponential condition, that is e power minus ny, right? So this is more appropriately it is coming. Now this is phi of x comma y. So the last boundary condition, that is phi of x comma 0. This is actually phi equal to u naught. Now phi of x comma 0. So this value is C1 C4 sin nx e power 0, and this is coming out to be u naught. Now as I told you earlier, so this is Bn sin nx sigma n is equal to 1 to infinite. This value is coming out to be u naught. Got it? Then this is going to be Bn is equal to, so this is a half range, this is a Fourier half range sine series. Half range sine series. Now in this Fourier half range sine series, Bn value you can find out integral 2 by pi. So the L is pi. Integral 0 to pi u naught into sin nx dx. So this is going to be 2 u naught by pi into integral sin. So minus cos nx by n, and the upper limit is pi and the lower limit is 0. So this is minus 2 u naught by pi, and then cos nx. So cos n pi is minus 1 whole power n minus 1. Got it? So note down till this point. I am going to erase it and write the final solution. Done? Fine? So now actually the final solution is going to be, what we have got based on this understanding is, so phi of x comma y is equal to minus 2 u naught by pi into, so minus 1 whole power, yeah, so minus 1 whole power n minus 1. So this you can write as 2 u naught by pi into 1 minus minus 1 whole power n. So this is going to be, for any even number this is going to be 0, and for any odd number this will be 2, right? So I will write this as 2 u naught. So this is going to be 4 u naught divided by pi for all odd numbers. So this is going to be the Bn, sorry, this is Bn. So phi of x comma y is equal to sigma n is equal to 1 to infinite Bn sin nx into e power minus ny, where n is an odd number. So this can be written as 4 u naught by pi. If you take it out, this can be written as, so e power minus y into sin x plus e power minus 3y into sin 3x plus e power minus 5y into e power into sin 5x plus dash 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 up to infinite. So this is the kind of variation what you are going to get at any instant, the temperature value. Got it? Yeah, I think so. N is in the denominator. Yeah, that's correct. So if it is in the denominator, this will be 1. This is 1 by 3. This is 1 by 5. Got it? Understood? How to solve the Laplace equation? So the most advantage of all the 3 applications of this partial differential equation solutions, that is the heat equation, the wave equation and the Laplace equation, the procedure is 100% same. There is no difference. So you are solving exactly in the similar manner, but you should be intelligently adopting the boundary conditions and identifying the boundary conditions. That's the only difference. So other than this, there is no other difference. You will be able to solve it easily. Got it? Any questions on this applications of the partial differential equations? Any questions? Anybody? Got it? Fine. So that's all for today. So in the next class, I am going to deal with maybe the canonical forms and the method of characteristics. With that, we are going to end it. Only 2 classes left over. Got it? Yeah. So that's all for today. Thank you. Good night.